Hey guys, today we're going to be talking about systems of inequalities a little bit more. Last week we solved systems by using substitution, but this week we're going to talk about how to solve systems by graphing. Okay, and this will be very similar to solving systems of inequalities, but there are a few different differences. Okay, so let me go ahead and show you those. Okay, so on the left, I'm going to show you how to do a system of inequalities, and then on the right we'll do a system of linear equalities, or an equation. And you'll see the differences and the similarities. Okay, so on the right we have the equation, or the inequality y is greater than or equal to 2x. And we're going to go ahead and graph this. If you don't have a y-intercept, you have to assume it is, of course, 0. Okay, so we're going to go ahead and plot our point. Oops, let's go ahead and zoom in here. And then your slope is 2 over 1. So from your y-intercept, we're going to go up 2 and over 1. Okay, and then we're going to draw our line. And remember, with inequalities, you either have a dotted line or a solid line. And since we have an inequality that has a less than sign under, or equal to sign underneath it, you're going to go ahead and draw a solid line. Okay, and since all of our y values need to be greater than that line, you're going to go ahead and shade above it. Okay, this should be review of everything we covered last unit. Okay, so that's line number 1. Okay, line number 2, we got a y-intercept of 1. So we're going to go up 1. And our slope is 1, so we're going to go up 1 and over 1. Okay, and then we're going to go ahead and draw our line, and this time it will be a solid line. And we want all the y values that are shaded down. And remember, when we have systems of inequalities, you're going to shade the area that we have shaded twice, the area that overlaps. And the only area that happens is the area right here. Okay, so you could choose any of those ordered pairs and they would make both of these guys true. And so that is how a system of inequalities works. You're looking for the ordered pairs that make both sets of inequalities true statements. Okay, let's go ahead and move on over to systems of equations. Okay, this is just like graphing that we did several units back. Okay, you're going to graph your y-intercept first, then your slope, and then draw your line. Okay, so let's try the first one. Y equals 2x. Once again, there's no y-intercept, so we're going to assume it's 0. And we're going to go, our slope is up 2 and over 1. I'm going to do that a couple of times just so we can get a more accurate line. And then you go ahead and draw your solid line. Okay, so that is our first line, and our second line is our y equals x plus 1. So our y-intercept, of course, is going to be 1. And our slope is 1 over 1 on this one. So you're going to go from your y-intercept up 1 and over 1 for your slope. And then draw your line. Okay, now, finding solutions for systems of equations is a little bit different. Instead of finding the area that's shaded, you're going to find the ordered pair where it intersects. Okay, so that little blue dot right there, this guy, is where both lines intersect at the same time. So the ordered pair, 1, 2, would be your solution for this systems of equations. So you can see that while these graphs look similar, the solution sets are completely different. Okay, so that is the difference between systems of inequalities and systems of linear equations, or equalities. Okay, go ahead and skip this section. And we're going to go ahead and talk about the comparisons and the difference between the inequalities and the equalities or equations. Okay, so make sure you write these 4 different things down on your paper. Okay, so first thing about systems of inequalities. When you have systems of inequalities, you're going to have 2 lines, or 2 inequalities. Okay, so you have 2 lines and there will be 2 inequalities. Second thing, you will have shading. You'll shade all the different values that make that inequality true. Okay, third thing, the line that you draw through your points will either be a dashed line, or you will have a solid line, depending on which type of inequality you have. If you have dashed line, you'll have a greater than or less than, and if it's solid, you'll have a greater than or equal to, or less than or equal to. Okay, last thing about inequalities is you're going to have lots of solutions. Okay, the solutions are the area where the inequality has been shaded twice, or it overlapped. Okay, so those are the 4 things that you can recognize a system of linear inequalities. Okay, let's go on ahead and move over to systems of linear equations, or equalities. Okay, once again, you have 4 things. Instead of inequalities, this time you have 2 equations. Second thing, unlike inequalities, there is no shading. You just draw your line and you are done. Third, your lines can only be solid. There is no dashed line. So when you're doing systems of equations, you will always have solid lines every single time. And lastly, you have 1 solution, only where it intersects. So if you have a graph and you have 2 lines go through here, your solution is going to be right where they cross, so there's only 1. Okay, so make sure you have all these notes down. We're going to do a few examples on the back and then we'll be done. Alright, so let's try a couple of different examples. Okay, this example says, which ordered pair is a solution to the system? And first off, you're going to see that these 2 equations are not in slope-intercept form. And we need them to be in slope-intercept form, y equals mx plus b, where m is the slope and b is your y-intercept. Okay, so we need to go ahead and solve those for y. Okay, so let's go ahead and zoom in. We can solve these. Okay, so our goal is to get this guy by itself. So we want to undo addition with the x's and subtract 2x on both sides. Okay, those x's cancel, and we bring down everything as we see it. Remember, stuff on the right side of the equation cannot be combined because they are not like terms. Okay, so that equation is solved for. We have it in slope-intercept form. Let's try the other one. Okay, so this time we're going to add 2x on both sides. Undo subtraction with addition. The x's cancel, like Lizzie Borden chop chop, and bring down everything as you see it. Okay, so we have our 2 equations. We have them solved for y, and now we're going to graph them. Okay, so let's start. I'll graph this one with my blue line, and we're going to see which one of these ordered pairs ends up being the area where these 2 points cross, or these 2 lines cross. Okay, so on our first equation, we had y equals minus 2x plus 5. Our y-intercept is 5, so we're going to go up 5 spots on our graph. 1, 2, 3, 4, and 5. And you have your blue dot right there. Okay, so our plus 5 for our y-intercept, our slope is going to be -2 and over 1. Okay, so from your y-intercept, you're going to go down 2 and always right 1. Always right, no matter if it's a negative slope or a positive slope. And then, of course, we're going to draw our solid line. Okay, so there's our first line for our first equation. Our second equation, our y-intercept is going to be a positive 1, and I'm going to draw this line in our red. Okay, so we have a positive 1 slope, or a positive 1 y-intercept, so we're going to go ahead and graph that thing. And we have a positive 2 slope, so we're going to go up 2 and over 1. Okay, so from our y-intercept, we're going to go up 2 and over 1. And you can do that as many times as you think necessary. Okay, so let's go ahead and draw our line. Okay, and you can see that these two equations intersect at this ordered pair right here. I'm going to mark that in black. And that happens at the ordered pair 1, 3. Remember, our x comes first, y comes second. Okay, and we can see that that matches up with letter C. Okay, so there will be ones on your exam that will be like this one. You're going to have to solve for y, graph them, and see where they intersect. Okay, so that is our first example. Let's go ahead and try our last example. Okay, these ones are already solved for y. You don't have to do anything. You can go ahead and graph them. Okay, so our first one, we have a y-intercept of -7 and a slope of 3, or a rise over run of 3 over 1. So let's go ahead and graph that guy. I'm going to graph it in red. Okay, so we're going to go down 7 for our first point. 1, 2, 3, 4, 5, 6, 7. And of course our slope is up 3 and over 1. So from our y-intercept, I'm going to go up 3, 1, 2, 3, and over 1. And once again, you can do this slope as many times as you think necessary to make a straight graph. There we go. Okay, let's go ahead and draw our line through these points. And we're done with that equation. Okay, let's take a look at the second one. This time, and I'm going to mark this one in blue, we have a y-intercept of 5 and a slope of -1. Okay, so you'll do a rise of -1 and a run of 1. Okay, so let's go ahead and graph our y-intercept of 5. I'm going to go up 1, 2, 3, 4, 5. And our slope was -1, so I'm going to go down 1 and over 1. And I'm going to keep doing this until I hit my point on the red line. Down 1, over 1. Down 1, over 1. And then you can see that it hits it right there. So we're going to go ahead and draw our line. And you can see that the red line and the blue line intersect at where this black dot is. And that, of course, is the ordered pair 3, 2. Okay, so that is the solution that makes both of these equalities true. Okay, so make sure you have all of these notes. You will have a few problems of homework today. Great job, guys.